Hi friends. In this video, I gonna introduce a type of common passive tone control. You can see that the circuit has two potentiometers, one for the bass and other for the treble. Both bass and treble can be a boost or cut and may have either linear or logarithmic tracks, depends on the circuit design. The resistances of potentiometers are so higher than the resistance of resistors. The output is fed into a power amplifier circuit or other stage amplifiers. Before I start to analyze it, I need you to remember a formula to calculate a capacitive reactance. There are 4 capacitors is used in this circuit. I calculate values of capacitive reactance following the frequencies such as 20 Hz, 100 Hz, 1 kHz, 20 kHz. The capacitive reactance is inverse proportion to capacitance. It is easy to recognize. Now, let's get started. I suppose that the input signal contains high frequency, mid frequency, low frequency. They are signed by blue, yellow, red. The gray components are inactive. I also suppose that the wipers are set to maximum resistance, so that the capacitor C1 is inactive because it is B short circuit. The potentiometer VR1 is also inactive because so high resistance. The capacitor C4 is inactive because the potentiometer VR2 is inactive. The circuit is redrawn as following. The input signal is shared into 2 directions. I gonna the first direction, that is bass direction. The A point has full bandwidth of frequencies input. There is a passive low-pass filter inside the circuit. The capacitance of C2 depends on frequency. The capacitance of C2 is quite low, so that, the higher the frequency, the more are conducted to ground via R2. The blue signal has high frequency, so that, it is almost grounded. The yellow signal has mid-frequency, so that, it is decreased amplitude. The resistor R2 in serial with capacitor C2 prevents the attenuation of the mid-band frequencies exceeding about 20 dB. The remaining signals go to output via R3, so that, bass direction changes from full bandwidth into low amplitude with mid-frequency and full bass frequency. Now, I consider another direction, that is the treble direction. The B point has full bandwidth of frequencies input. Pay attention to the capacitance of C3. It has so high capacitance by low frequency, so that, it blocks low frequency and bypasses high frequency. The mid-frequency is a decreased amplitude. So that, the treble direction combines to the bass direction that changes input signal from full bandwidth into full bandwidth with an amplitude of mid-frequency is low, high, and low frequency is higher. We have a frequency response when set to the maximum wiper. Come back to our circuit. I suppose that the wipers are set to minimum, so that, C2 is inactive because of short circuit. VR1 and VR2 are inactive because of high resistance. The capacitor C3 is also inactive because VR3 is inactive. The circuit is redrawn as following. The input signal goes through resistor R1. The C point has full bandwidth. At here, you note that the capacitor C1 and the resistor R2 form a passive high-pass filter, so that, low frequency is blocked. The remaining frequency goes via R3. The capacitor C4 and the resistor R3 form a passive low-pass filter. The capacitor C4 is 22 nF. You can see that the capacitive reactance of C4 is low at high frequency, so that, the signal has high frequency is grounded. The remaining mid-frequency is less affected by the ground, so that, its amplitude is decreased. At output signal, we almost have only mid-frequency. We have the frequency response when set minimum potentiometers. Combine the maximum frequency response and minimum frequency response, we have a full frequency response. That is all my knowledge about this circuit. I hope you like my video. Don't forget like, share and subscribe to my channel. Bye.